Now, excuse me. What we are going to learn today is actually one of the things that we do in math class that has real life applications in many, many, many situations, and it applies to many, many other classes. And the neat thing about it is it doesn't matter what you're doing, why you would ever need to use this, it always works the same. So it's actually a really handy little thing to know about. Whoops, that shouldn't have happened. I'm still recording. Okay. It's actually a really useful thing to be able to do. So what we're going to start with is staying within our system. So converting SI to SI and imperial to imperial. Feet to yards, yards to miles, meters to centimeters, grams to kilograms. We're going to start with that. And then we're going to work into switching between the two, kilometers to miles, things like that. Because even though the numbers are different, the method is still exactly the same. All right? And the thing we are going to learn about today is this, proportional reasoning. Okay? Does everybody know what proportions mean? Like if I say something is in proportion to something else, do you guys know what that means? Pardon? It's not the same, exactly. Yeah. Okay. Proportion. Yeah, it's parts. Yeah. And when I say if something is in proportion to, that what it means is the comparison is always the same. Okay. So if I were to say there's 30 of you in here, and I want to give a cupcake to every kid in my class. All right. Well, how many classes do I teach? 4. So right now there's 30 of you in here. So how many cupcakes do I need?
120.
For in here, how many do I need? 30. Because it's proportional, because I teach 4 classes, it's got to be the same fraction. Everybody cool? So in one class, it's 1 cupcake for 30 kids. Right? But if I have 120 kids, which is how many kids I teach, I then need 1 cup, or that's the other way around. I screwed that up. I'm such an idiot. Don't write that down. No one's writing it anyway. Now my computer's frozen, so my mistake is up there for everyone to see. How embarrassing. Erase. Oh, now that won't erase. So embarrassing. I'm so embarrassed. I know, right? I'm going to pretend like it's not even there. No, it's not there. There's nothing written on the screen. See? There. Nobody asked you. No. I know his name is Jashandeep. That's not what I'm saying. What I'm trying to say is, when he gave the answer that I need 120 cupcakes, he knew that I needed 120 cupcakes because I needed 30 for one class, and I told you it was proportioned. So he knew if I made the class 4 times bigger, I needed to make the amount of cupcakes 4 times bigger. That's what I was trying to say. Everybody understands that, yes? Okay. So now we're going to talk about what is happening. And I've left this blank space here for a reason, because here's where we're going to write how we do this, okay? For any conversion, and this works in math class, physics class, chemistry class, it doesn't matter. It works all the time, okay? You take the original amount, the amount you are starting with, and you multiply by the following fraction, okay? The fraction is this, what you want over what you have. And that gives you your answer, okay? Now right there's no numbers in that, so it seems confusing, right? Because there's no numbers, this is math class. You guys dig numbers, you want to see numbers. So, what we're going to do is we're going to start with a super easy one, and I'm going to show you how it works. Okay? So this super easy one is right here. Convert 485 centimeters to meters. Now, you guys are smart kids. How many centimeters are in a meter? 100. So 485 centimeters must be 4 meters and 85 centimeters, yes? And since it's SI, it would be 4.85, right? And we can do that in our head, no problem. And the mistake that you guys make is when you can do something in your heads, you don't realize that you're actually doing math, even though you think you just know the answer. Do you understand what I'm saying? Yeah. Here's what I mean. All of us knew that this was 4.85, yes? Because it's SI. So everything works in tens and hundreds, right? So we can just do that in our head. But if it wasn't SI, how would we do it? Well, we would follow this fraction thing. And here's what I mean. What is the original amount that we started with? 485 centimeters. So we would write that down. 485 centimeters. Okay, no problem. Now, technically in math class, 485 is always over 1, isn't it? Okay? So just remember that. Then we have to multiply by the fraction, what we want over what we have. Well, what do we want to convert to? Meters. So we want meters on the top, and pretty soon an M will show up there. And what do we have? We already have centimeters, yes? Everybody cool? Okay. Now, then we go up to our little chart here. And by the way, you do not have to memorize this chart. You will get it on your tests. Okay? We go up to our chart up here, and we already know 1 meter is 100 centimeters because we know that in our heads. But if we were doing a measurement that we didn't know, we'd find it on the chart. Okay? And we see it right here, yes? 1 meter, 100 centimeters. So I go to my fraction here, and I see meters. That gets the 1, and that gets the 100. Everybody cool? Now, you guys are smart kids. Centimeter in the numerator, centimeter in the denominator. If I have the same thing on the top and the same thing on the bottom in math class, and they're numbers, what do I get to do? Cancel them out. So do you think I get to cancel out the units? Yeah, I do. So they're gone. So what I end up with is 485, because 485 times 1, over 100, yes? And then I just do that with my calculator, and I get 4.85. Does everybody see? Now, we already knew it was 4.85 in our head, but that's how we do it with math. So when we approach something that we don't know automatically, we can still follow this. Everybody good? Now, this comes into play in real life all the time. Because when you guys go to a store, you buy stuff, yes? And especially in food, what are we often taught? Buy food in big quantities, yes? Because it's cheaper, right? Sometimes it isn't. Store people know that. They will try to mess with your head. And the worst company for it is Walmart. Walmart will sell stuff in little boxes. And it will sell stuff in big boxes. And often the stuff in big boxes is more expensive than the stuff in the little boxes. My example that I always like to use is kitty litter. I have cats, I have to buy cat litter. Giant box of cat litter you would think would be cheaper than 3 little ones, yes? But when you do the math, you find out it's not cheaper. People have been trained to buy big amounts, so they buy the big box, and Walmart actually makes more money off of you. When Target was still open, I was in there once, I was trying to buy an energy drink because I had to drive to Portland in Oregon, and I was like, oh, I'm going to be sleepy, I'm going to get an energy drink. And I went into Target to buy an energy drink, and they had those 5-hour energy drinks. You guys know those little ones? Yeah, you shouldn't drink them. They're really bad for you. But one of them was $2.99. Okay? They had a pack of 4 for $13. And they had a big sign, 4 5-hour energy drinks, $12.99. Right? Do the math. Everyone was buying 4 packs, but the singles were actually cheaper. right? Because you only need one. Anyway, so let's use this in one that we don't know automatically. So here we have 57 inches. We're going to compare it to feet. So what do we start with? 57. And I'm actually going to write inches instead of the little quotation marks. Then I got to multiply. What do I want? Feet over inches, yes? Now I go up to my chart and I find feet in inches. Where is it? Right here. 1 foot is 12 inches. So I go down to my fraction I've set up. The feet gets a 1, the inches gets a 12. Cancel the inches, and I'm left with 57 over 12. And when I do that math, what do I get? If you need your calculator, you need your calculator. It's no big deal. Actually, I want you to get your calculator because it's going to do the next thing I have to teach you. Pardon me? 4.75. What's wrong with that answer, Jazreet? Pardon? It needs a unit, right? But still something's wrong with that answer. Carlin? It's decimals. I'm 5 foot 8 inches tall, yes? Do I say I'm 5.67 feet tall? No, I say 5 foot 8 inches. So can I leave it like that? No, right? So this is the next thing I have to teach you. When we are measuring in imperial, we can't leave that decimal there, can we? So how do we fix it? We know it's 4 feet and something. I don't know. I'm asking you. Here's what we do, technically. We know it's 4 feet and 3/4, yes? So in our heads, we know a quarter of a foot is 3 inches, yes? And I know I need 3/4 of that. So it's 4 feet 9 inches, yeah? So here's what we do. 4 feet covers how many inches? 4 times 12, yes? So that is 48 of our inches. But we needed 57 inches, yeah? So the remainder, remember back in grade 3 when you were learning division and there were remainders left over and you just wrote R equals 3? Remember that? This is why. Remainders are important later on in math. We're at that later on. So it is 4.75, which is 4 feet 9 inches. And if you ever need to work it out, you don't know it automatically, then you can do this. Don't write this down. 0.75 feet is what I had. Yes, that's what I didn't know. So don't I know how to change things? I still multiply by inches over feet. 12 inches, 1 foot. So if I do 0.75 times 12, I'm going to get 9, and that's my leftover inches. Everybody with me? It's exactly the same thing we already did, but we have to remember we can't leave decimals in imperial. Good? All right, let's try the next one. Yards to feet. So what do I have? I got 15 yards, and then I'm multiplying by, I want yards to feet, so I want feet. So it's on top, yards is on the bottom, and then I go to my conversion chart. You already know this one in your head. How many feet are in a yard? 3 feet is 1 yard. What happens to the yard? They cancel. So then I get 15 times 3, 45 over 1. So it's 45 feet, because 45 over 1 is 45. Everybody cool? Okay. Let's have a look at this one. 136 feet to yards. So I got 136 feet. Now I want yards. So I want yards, so it's in the numerator spot. Feet is in the bottom. We know 3 feet is 1 yard. Now you should already be seeing a shortcut here, yes? When the 1 is on the bottom, what math did we do? Multiply. So when the 1 is on the top, what math are we going to do? Divide. So this becomes 136 over 3, which is what? What's 136 divided by 3? Oh, actually, I'm glad that happened. Keep your calculator out. Actually, may I borrow it for a moment? If your calculator does this, leaves you in fraction form, then here's what you need. Does anybody else have a calculator that's doing this to them? Okay, then you need to look for this button right here. SD. Let me focus that. See that SD button? When I hit that, it changes it to a regular number. Everybody cool? Okay. So what's wrong with that regular number, 45.33? It's a decimal. 0.33 is 45 and 1/3, isn't it? Oh crap, I gotta push that button. It's 45 and 1/3, yes? Well, what's 1/3 of a yard? One foot, right? So even though the math is easy, we still got to keep stuff in our heads, right? So the real answer here is 45 yards, 1 foot. Does everybody see what I am saying? Is everybody cool? Because we're not allowed decimals in imperial measurement. Everybody okay? All right. So let's look at this one. What is the 2 little ticks? Inches. So I'm going to write that out in English because I don't like those little inches thing when I'm doing math because it's hard to remember how to cancel it. So 2016 inches, and in a moment that will appear, times, what do I want? Feet over what I have, inches. Then I fill in the numbers. It's 1 foot for 12 inches, right? So since the 1 is on the top, is this a multiply or divide situation? Divide. So it's 2016 divided by 12. What does that give me? Is it going to be perfect? No. What does it give me? 168 perfectly. It was perfect. Feet. 1 line or 168 feet. Everybody cool? All right, now look at number 6 and tell me why is number 6 a badly written question? Because there's a decimal, right? Now, how many times already in math have I said in this room that looks don't matter? A couple of times, and if you were in my class last year, 1,000,000 times. Do we change the math we do? No. So we want miles to feet. So we start with 4.2 miles, because that's not our final answer, is it? We wouldn't leave a decimal in our final answer, right? So, and I want feet. So what goes on top? Feet. What goes on the bottom? Miles. And I look on my chart. What goes in the numbers? The mile is 1. And what goes in for feet? 5,280. Now, the 1's on the bottom, so is it a multiply or divide situation? So I got to do 4.2 times 5,280. What does that give me? I don't have my calculator out, so I'm trusting you guys. I'm sorry, Alyssa? 23,760. With no decimals? So as you can see, our decimal took care of itself. Everybody okay with that? Now, guys, stop for a moment. Are either of these a real life math problem? Would somebody ever come to you, a carpenter, and say, I need 2016 inches of 2x4s? No. He wouldn't, would he? Or she? Would somebody ever come to you and say, I gotta walk 4.2 miles. Can you tell me how many feet that is? It's stupid, right? I live 20 miles from here. Would I ever say I live 20 times 5,000? Would I ever say I live 104,000 feet from work? Right? That's stupid. Why have I put them in your math class? Because I need you guys to see that even though we would never measure that way, we would never measure a distance that long in feet, the math still works. So even if we were doing something that we would never use those distances for, we can always work it out because the math works even though it looks stupid. Everybody cool? Okay. Let us move on then, cabbages. You're new here. You don't get the joke. Let us move on. Let us.
Oh, I got it now.
Cabbages. Now, what happens if we don't have a direct conversion? So by that I mean here. I've got yards to inches. So when I look on my chart, does that one exist? No. It actually does. It's right there. Yards to inches. So we're going to be okay, right? So let's try that one. You guys write that out on your own. Write it out properly. And then when you get to it, tell me your answer. I need one of my calculators because I want to do these along with you guys, and I don't have the answers memorized. Thank you. That sounds about right. Everybody cool? Am I missing a zero? Oh, yes. I only have 18,900. Thank you. I'd love to say it was a test, but no. I just screwed up. Millimeters to centimeters. Is that on our chart? We set it up first. 1,250 millimeters times I want centimeters over millimeters. Is that on our chart? Yep. 1 centimeter is 10 millimeters. The one's on the top, so is it a multiply or divide situation?
No divide.
Divide. So it's going to be 125 centimeters. Cool? Okay. Is number 9 written in a way that we're okay with? Why? I thought decimals were a problem. Why is that one okay?
We solved it then. We just solved it then.
Yeah. So we're going to have 37.25 meters, and I want centimeters. So I want centimeters over meters, 100 over 1. 1's on the bottom, so is it a multiply or divide situation? Multiply. Well, if I'm multiplying by 100, how many times do I move that decimal? 2. 3,725 centimeters. Don't even need our calculator for it. And people still say the metric system is too confusing. Last one. This is my favorite one because this one is, one of those math problem ones, right? Would you ever measure 17 millimeters, which is this much between my two fingernails? Would you ever measure that in kilometers? Of course not. But does the math work? Yeah, we still follow the same rules. 17.2 millimeters. And now I need kilometers. Now, because we would never make this conversion, is this conversion on your chart? No. It's not, is it? So we need to get that onto our chart if we don't actually understand, right? We've got to skip steps. What can I do on my chart? I can do millimeters to centimeters, right? So if I go centimeters and millimeters, I'm going to get 10 to 1, right? And that's going to get me to centimeters. But I don't want centimeters, do I? What do I want? Kilometers. Can I go centimeters to kilometers? Centimeters to kilometers? Can I go centimeters to meters? So could I go meters to centimeters. And that would be 1 and 100, right? Then, at this point, I've got centimeters. At this point, I've got meters. Do I need one more step? Yeah, because I can do meters to kilometers, right? So now, I want my kms on the top. It'll show up in a second. Meters on the bottom. 1 km is 1,000 meters. And there, I'm at kilometers, yes? So how does this work? Do the ones matter? No. So on the top, I've got 17.2 times 10, don't I? What's that? How many decimal places do I have to move to be times 10? 1. So I've got 172, yes? What's on the bottom? 100 and 1,000. I got to multiply them, so it's going to be over 100,000. And then I can get my answer. Everybody cool? I just keep stacking it up. So if I ever have to go more than one step, I just fill in the steps following what already works. Everybody good? So if I wanted to go inches to miles, what would I do? Because there's nothing on my chart that's inches to miles, is there? So what would I have to do? I can go inches to what? I can go inches to feet, and then what would I have to do? I could do feet to yards, but isn't feet to miles on my chart? So I could go feet to miles. So it would be a 2-step one. Everybody with me? Cool? Okay. So now let's do some actual real-life problems. I got a plank at 6 foot 4 inches. How many? 6 feet 4 inches. How many inches long is the plank? Well, if I need to know inches, do I have to care about the 4 inches? No, I only need to care about feet, right? So 6 feet. And what do I want? Inches over feet. 112. Numbers on the bottom, so it's multiply. How are we with our 12 times table? 72. Is that the right answer? Why? Because I had this other 4 inches. So I add the 4 to get 76 inches. Everybody good? This is the easy stuff, right? When we're staying in the same system, right? This is the easy stuff. But remember, the math works the same tomorrow when we start going between the two systems. It's the exact same stuff. So what's this next one? 5 yards, 2 feet, and I need inches. Which I might very well need inches if I was buying something that was sold by the inch. So how am I going to change this? I need yards and feet to inches. More than one way to do it. Stop for a second and think about it. What are you planning to do? You don't even have to write it down. You just got to think about what your plan is. Would anyone like to volunteer what they were going to start with? Nobody? Oh, Jazreet.
I would have converted 5 yards individually and then added it together.
Okay, so you did this to feet, and then added 2, and then went to inches, right?
No, I would have converted the yards to inches.
Oh, you went yards straight to inches.
Yeah.
Okay. So she went 5 yards to inches, and then feet to inches, and then added the 2. That's what you did? Cool. Is that okay?
Yeah.
Is it more right or wrong than any other way? No. And that's where grade 10 is going to mess with you guys a little. Up till grade 10, there's often only one way to do stuff, right? And if you learn that way, you were in business. But now, as you are well aware, math has gotten slightly more complicated as you've gone along, yes? Well, the universe goes on forever. Math is complicated. As you get further and further along, you're going to find more than one way to do things, which is why I'm going to do what I just did a lot. What was your method of starting it? That was Jazreet's method. Did anybody do something differently? There's the one I just said. We could have converted that to feet, right? And then added 2 and then converted that to inches. Would that have been okay? Yeah, it doesn't matter what you do. So everybody choose a method, find me this answer, and then we'll see if you're right. Okay, I'm going to do some of this in my head because I know this yards to feet is times 3 because I've been practicing a lot, right? So I know I've got 15 feet plus 2 more feet is 17 feet. And then I need to go to inches. So I'm going to multiply by inches over feet, 12 over 1. Number 1's on the bottom, so it's times 204 inches. And the other way you might see that written is, of course, 204 with quotation marks as opposed to an apostrophe. Everybody cool? Okay, number 13 is a bit of a trick question. So again, figure out what you would do. Take a moment and read the question first. What's weird about it? Yards and inches. So I've got to do a conversion, don't I? What should I convert? Should I convert inches to yards or yards to inches? Does it actually matter? No. But Carlin wants to go yards to inches. Okay, no problem. So we know that 6 yards, if I'm going to inches, I want inches, yards is on the bottom. What's the numbers that go in there? 36 for inches and 1 for yards. The 1's on the bottom, so is it multiply or divide? Multiply. 6 times 36 is what? 216 inches of fabric, yes? What am I cutting it into? 5 inches. What math is cutting something up? Division. So what math do I do here? Divide by 5. And what do I get? 43.2. Now, how many of you want to stop there? I'm glad no hands went up, because that's not the right answer, is it? Can't be a decimal. How can you make a ribbon, 0.2 of a ribbon? You can't, can you? That's like saying I got 0.2 of a brother. You got a foot, right? Or a hand. What's the question? How many banners can be made? So how many banners can we make? 43 banners. Because we can't complete that last banner. Everybody with me? Now here's what math teachers like to do to you guys. What if I told you we had, and don't write this down, just what if. What if I told you we had 220, wait, let me do a quick bit of math. What if I told you I had 219 inches? What would you do? Would you still divide by 5?
Yeah.
Okay. So what does that give you for an answer? 43.8. How many banners can I make?
43.
Still only 43. See the difference? When we were in grade 6, what would you have done with that number? Rounded it up to 45. That's not real life, is it? I can't make a 44th banner. So even though we would have rounded it up in grade 6 math class, in real life we can't do that. So you have to know what is happening as well as knowing the math. Does everybody understand me? Cool? All right. So let's have a look at a couple of these questions. Perform the following calculation. 2 kilometers minus 755 meters. Why can I not do that question right now?
You have to convert.
I have to convert, don't I? Because I can't do 2 minus 755. Which one do I convert? Does it matter? If I convert kilometers, how many meters are in a kilometer? 1,000, and I have 2 of them. So how many meters do I have? It's either 2,000 minus 755. That'll get me meters. Or I can leave that as 2 kilometers, but what would I have to do to this guy? Change him to kilometers, which is 1,000, right? How many steps of the decimal for 1,000? 10 is 1, 100 is 2, 1,000 is 3. So I have to do 3 steps, right? So it would be 2 kilometers minus 0.755 kilometers. And they're going to give me the same answer, but one is in meters and one is in kilometers. Is everybody with me? Are they both right? Are they both right? Because I didn't ask, did I? You can give it to me in either one because that's what's good about SI. So it's either 1245 meters or 1.245 kilometers. Is everybody cool? All right. What's weird about the next one? Because it's slightly changed. What's changed about 15? I've told you what I need. I need kilometers. So, do I care about that one? He's okay, right? I have my 1.35 kms. But is this guy okay? No, but I know meters to kilometers is 1,000 because that's on my chart, right? So it's 3 steps, right? So what is that as a kilometer? 0.125. Now, where's the problem? Right here, right? Now stop for a second. We know we could go step by step by step like we did over on the other side, right? Right? We know we could go centimeters to meters, meters to kilometers, couldn't we? But we also know that meters to kilometers is 3 decimals, right? So can I change that to meters in my head? How many steps is it to go centimeters to meters? 100. So how many decimal steps is that? 2. So isn't this 0.4 of a meter? Isn't it? Okay, so I've moved it 1. Then I already know that it's got to be 3 more here, don't I? So I got to move it 3 more steps. 1, 2, 3. What goes in those blanks in math class? Zeros. 0.0004. Is everybody picking up what I'm putting down? So if I know what I'm doing, I can work in my head. But if I don't, I can always go back and use the fractions, right? Who decides what I do? Me or the math teacher? You. You're going to decide. If you can do that in your head, do it in your head. But if you need to use those fractions, is there any shame in using those fractions? Absolutely not. That's what they're there for. Everybody good? So look at 16 and tell me what you wouldn't change. You don't need to change the 12. So that guy's good. But what do I need to do with miles? Turn it into yards. So I have miles and I need yards. So I got to check my chart, right? Yards is what I want. Miles is what I have. What's the numbers? 1,728 over 1. 1's on the bottom, so is it multiply or divide? Multiply. So first I got to do 4 times 1728. Can I do that in my head? No. So I get out my calculator. What is it? 7,040? Exactly? Oh, have you added the 12 already, Rihanna? Or whoever said that? 4 times 1728 can't be 7,040. 6,892. That's plus the 12. So it was 6,800. I gotta get my calculator out now because you guys are killing me. 1728 times 4. 6,912. And then I add the 12. What do I got to do with this 13? What?
Yards are 1,760 yards.
Oh, it's not 1728. Oh, that's why I wrote it down wrong. Sorry, guys. Thanks. My fault, not yours. I don't know why I thought it was 28. So 1760 times 4. There we go, 7,040. Sorry, Jazri, I'm an idiot. I wrote 1728. I did the right math, but I wrote it down wrong. Actually, this is a good thing to have happen. What if you do that on a test?
You got it wrong.
Carlin, would I yell at somebody for that?
No.
That hurts, man. What would I do? Do you think in the 10th grade, if you wrote down 1728 and did the math, got 6912 plus 12, and showed me all your work, questions out of 3, what would I give you, Carlin?
Like, 2 out of 3.
I give you like 2.5 out of 3. You'd still get the A. Why? Because I care about the math. Do typos happen? Yes. Right? They happen all the time. You guys send texts to each other. You've sent some pretty funny texts. Right? I've told my friends that are girls that I'll meet them outside in a sex. What did I really mean? Sec. But what did my iPhone correct it to? Because that's not a word. Meet you outside in a sex. They're like, no, thank you, but I will meet you outside. It happens all the time. So please be aware, if you make an error like that, and it's close, you're not going to get punished for it. Okay? Picking up what I'm putting down? So anyway, so we fixed that up. Now what do I do with the 13 inches? Do I need to convert it to yards? Yep. So it's going to be times yards over inches. So it's 1 yard, 36. It's 13 divided by 36. Now, since this is imperial, do I want that decimal? No. So it's 7,040 plus 12 plus 13 over 36, which is 7,052 and 13/36 of a yard. Now, is there a way to make that one step better? What do you think it would be? Because that's the right answer, right? Can I make it better? It's not going to be any more right, but can I make it better? How many inches is that? 13 out of 36, isn't it? Don't I know something about inches? 12 inches is what? A foot. So could I also write 7,052 yards, 1 foot, which covers 12 of my 13 inches. How many inches did I need to cover? 13. So what was my remainder? 1 inch. Does everybody see that? Am I happy if you get to there? Yes. Am I super happy if you get to there? Yes. Are they both an A-level answer? Which is an A, and you get an A and a G for work habits. That's the bottom one. What's this one? That's the A and the S. Picking up what I'm putting down? They're both right. The more math you can show, the better off you're going to be, especially as you go further along. Everybody with me? Remember, you're not going to get punished ever for doing the correct math. All right? If you can make it prettier, make it prettier. Cool? Cool. All right. Number 17 is easy. Number 18 is hard. What do I got to do for 17? How big's the picture? Look at it closer. 3 foot by 5 foot. The framing is done by the inch. So what do I got to do? Convert to inches. That's easy, right? Feet to inches. 3 feet. And I want inches over feet. So it's 12 over 1. No problem at all. What do I get? 36. And then I need 5 feet. Yup, go. Yeah.
I need to go. But my mom is
Yes, go. 12 over 1 to get 60. Correct? So how many inches of frame do I need? $96? Okay. So here's my picture. Wait a minute. Here's my picture. It's my self-portrait. Right? And because I'm very high on myself, I want a 3 foot by 5 foot self-portrait of me. So that's what's going on the wall. 3 by 5. What did we forget, Eden? There's another 3 and another 5, isn't there? So what do I have to do to that answer of 96, which was absolutely right? Right. I got to multiply it by 2 to get 192 inches. Now, why is this question in the notes? Because how many of you stopped at 96? Be honest, it's practice. Did anybody else stop at 96? What would I give you, do you think?
2.5.
Out of 3.
2.5.
That's a 2. Because you understood, you did the conversion, right? But then, did the answer make sense? No, because you could only frame half my picture, right? Okay. What about 18? You may need to work with a partner to do that right. The frame is 1 inch thick.
So 4 inch.
Does your answer change?
Yeah.
Why? Here's my picture again. I'll draw it again. Oh, he's a good-looking cat. Does it change? That's the picture. I want a 1 inch frame around it. We know that the picture is 60 by 36, correct? Now I want a 1 inch frame. So where does the frame go? Around the outside, doesn't it? Right? So now, how long is this? An inch longer? 2 inches longer. So that's 62 now, isn't it? Right? How long's this?
1 inch longer.
Why is it only 1 inch longer?
Because he accounted for the extra on top where he did 60.
So, again, there's more than one way to answer the question, isn't it? That's why I got it on here. If your frame looked like this, and I put straight across the top and straight across the bottom, I'd have 62 and 62, and then 36 and 36, wouldn't I? What if it was framed like this? Here's me. Right? Then what do I need across the top? Then I need the whole 62, don't I? And what do I need down here if I put diagonal corners? I need 2 more, so it would be 38, wouldn't it? Everybody with me? In grade 6, the questions have one answer, don't they? In grade 10, you got to think. Picking up what I'm putting down? Everybody with me? Is there one right answer to number 18? No. So what would you have to do if I gave you a question like that on the test? Make sure you explain what you're doing. Picking up what I'm putting down? So what's the question that I should never hear on a test? Do I have to show my work? Do you?
Yeah.
Yes. Good. You guys are brilliant. Number 19 is here on purpose because this was a question off an old provincial exam. What's wrong with that? It's a horrible question. I would never give it to you on a test because I'm smarter than the people that wrote provincials. What's wrong with that question? Everybody read it themselves. Think about it for a second. Tell me what's wrong with it. Because I'm telling you right now, there is something absolutely horrible about that question.
Is it linear?
Do you know what that means? No. Is there another thing wrong with this question? Decimals are okay. That's money. We have money in decimals. What's crown molding? Who knows what crown molding is? 30 brains in here. Nobody knows what crown molding is. What is it? See? I know, exactly. You don't know, do you? It's a horrible question, right? Okay, think about your house. Oh, Jasreet, do you know what it is?
Isn't it that on the wall, that white part at the top?
Yeah, think of your house or houses your friends have been in where the wall meets the ceiling. We have wall meeting the ceiling, right? But in a lot of houses, they have that extra piece of stuff, right? That's what it is. So here's my wall, here's my ceiling, here's my wall. And in a lot of houses, they don't want to see that corner because it's hard to paint. So they put this thing in. It's usually shaped like this. And it goes all the way around the ceiling. Right? Because then you don't have to paint to the edge. Because when you have to paint to the edge, sometimes you get paint on the wall from the ceiling or paint on the ceiling from the wall. I know this because the idiots that painted my house before I bought it didn't want to put in any molding, so we painted it ourselves, and I'm looking around, no kidding. Because they did a crap-ass job. Picking up what I'm putting down? So what's wrong with that question? Could you guys have done that question? No, because you don't know what crown molding is. Linear foot was what Josh... You know the whole thing, right? Josh and Deep, right? What Josh and Deep says. What's a linear foot? What word do you see in linear?
Line.
Line. So what do you think a linear foot is? Ear. Did you say ear? What's a line? What is a line? It's just a straight distance, right? So, me to Wyatt, right, is a straight line, yes? No matter where I measure it, I would just measure a straight line. You with me? Even if I were sitting on the ceiling, if I were to go straight across to where Wyatt was, it's just a straight line. So this just means a straight line. Doesn't matter how big it is, it's going to be that long. Understand? I'm 5'8" tall. Height is a linear measurement because it's straight line. Bottom of my feet, top of my head. Right? If I was super duper skinny, would I still be 5'8"? Yeah. If I was like one of those people on my 600-pound life, would I still be 5'8"? Yeah, I might have shrunken a little, yeah. But you understand what I'm saying? That's what linear foot means. So now, can we do this question? Yeah, because we know now crown molding goes along the walls, right? So here's my room, 185 by 240 inches. Where does the crown molding go? On the ceiling, along the wall, yes? So I need this 185. I need this 240. Then what do I need down here? Another 240. And what do I need over here? Another 185. So I need 480 plus what's 185 and 185? Do you know it in your head? Probably not. So you add it up, and what do you get? What do you get when you add 185 and 185? 370. So then I add that, and what do I get? So I need 850 inches of crown molding, right? When I go to the store, if I'm trying to do this job for somebody, I got to give them an estimate, yeah? I know the store sells it for $3.79 a foot, so what do I got to do with that? Change it to feet. 850 times inches, and now I want feet. 1 foot, 12 inches. The ones on top, so is it a multiply or divide situation? 850 divided by 12, and what do I get? 70.83333. How much crown molding do I need to buy? 71. Because if I only buy 70 feet, I don't get all the way around and I leave a little gap and somebody's mad. Should I only buy 71? Am I going to be perfect? You got to be real careful, right? If you were doing this as a job and you had to drive all the way to Home Depot, would you buy exactly 71 or would you buy yourself some extra? You'd buy some extra, right? But the question doesn't say that. The question doesn't say if you're a carpenter, what would you do? The question says how much crown molding do you need? So you would need 71 feet, right? But the question is how much? So what do I got to do with 71? Times 3.79 to find an answer. Everybody picking up what I'm putting down? Math 10 is where we try to get real life involved. You guys are going to do page 20 right now, and page 21 and 22 is homework. Okay? I'm going to pause the video because in about 5 minutes, we're going to come back to that question to page 20. So work on that for a little bit. If you finish before I've gone over it, carry on to the next page. Everybody cool? Are you allowed to move around now? Yeah. Can you sit with your buddies? Yeah. Can you listen to music? Yeah. As long as we're working, right? Go. Pardon me? Yes, please do.